So if you approach the moment of where chimpanzees and humans had a last common ancestor, somewhere between 6 and 8 million years ago, around that time frame, it's very likely that our shared ancestor was living a good part of the time in trees, maybe on the ground as well, but then using on four legs like chimps do most of the time. Having said that, same story. If you actually give a whole bunch of tasty fruits to a chimpanzee, then they're almost human in their greediness. They would grab with both arms. They would grab as many fruits mangoes or something like that, as they can possibly carry, and they will walk off on two legs. They're waddling. They're not very good at it. But they can walk. But you will see that their knees are bent, and you will see that their hips are really bent, so they can walk like 100 meters. But it's effective for them because they grab all the fruits that they can grab and walk away from the competition. Because if their supposed friends come along, and it's a dominant male or something, they might beat them up and saying, "Give the fruit to me." So getting out of the way and carrying all that fruit around, they even do that. But still, the earliest ancestor was probably largely a climbing animal, like majority of primates are. So at some stage they got out of the trees and more on the ground, and so the reduction in the number of trees that is associated with the environment changing and becoming drier, so that you get more savanna and fewer forests in Africa, and we have good evidence for different periods of time when that happens. That is probably really a driver. Now you can ask yourself, why did humans then start to walk on two legs? Instead of, let's say, baboons or any other monkey that is on the ground, or if you go to the zoo, half the time they're on the ground, and then you see they just walk on all fours, and they just put their hand flat on the ground.
Hello everyone, welcome to this episode of Little Brains Big Topics. Today we're honored to have Professor Fred Spoor to discuss human evolution with us. Would you like to introduce yourself, Professor, and tell us what projects you have been involved with?
Yes. Late in life, actually, only 2 years ago, I made quite a career change, because up till the end of 2017, I worked for University College London, and I worked there almost 25 years. So I've always been in academia. I worked in a medical school as an anatomist, so I would teach medical students anatomy, so how the human body is built. And for my research, ever since my PhD, has indeed been on human evolution. I have a background originally in biology. And that's also how I then got involved in paleontology, studying the past through fossils. And for my PhD, which started in the Netherlands originally, between 1987 and eventually getting my PhD in 1993, I did work on human evolution, and in particular at that time, the idea of studying fossilized remains with CT scanning, with radio, with X-rays, and getting sort of cross-sectional images out of that. That was all very new, and I took that to an advantage and worked a lot with Philips Medical Systems in the Netherlands. So we started experimenting with this, and eventually, sort of halfway through, I was invited by people in Liverpool to come and work over there, again teach anatomy to medical students. And do the second half of my PhD over there, and then very soon after I was finished, I was hired in London, and I've been there ever since. And now for the last few years, since 2018, I moved to the Natural History Museum in South Kensington to work there with colleagues, and now I can entirely focus on research. So there's no more teaching to be done. But yes, the anatomy teaching I've done for almost 30 years. So in that sense, it is a welcome break, and it's a great thing to be able to really concentrate on your research. So that's what I do now, and most of my research is actually in Africa. Ever since my PhD, I started working there. Particularly afterwards, I started to work in Kenya, and subsequently in Ethiopia, and a little bit in Tanzania, but mostly in Kenya. Two things. Both I pursued this thing that I was talking about of studying the fossil remains with X-rays, so that you could actually look inside, that you don't only look the outside, but you can actually see what's going on inside. And if you ask me why is that important, well, if you think about a skull or a head of a human or something similar, if you can look inside, then you can look at the area, the surface where the brains sit. And of course, brains are very important in human evolution. And something I specifically developed is that you can also look at where your ear is sitting. And then I don't mean your external ear, as you can see here, but inside your skull, you have what you call your inner ear, and that is your organ of balance and your organ of hearing. And by studying that, you can actually, because balance has something to do with walking on two legs instead of four, you can study in a completely new way. You can study how humans eventually evolved from creatures that walked on four legs or climbed with four limbs to something that was bipedal on the ground like we are. So it was a completely novel approach. And in Kenya, they invited me to come and work at the National Museums of Kenya in Nairobi and start studying their fossils with this new technique. I set up a whole program for them together, initially just in hospitals to bring the fossils to the hospital and put them in a scanner. People may notice if you've been to a hospital and you had a brain scan done or something, then that's a CT scanner that peers inside your head or inside your pelvis or inside your knee or wherever you want to look inside, you can do that. And I also started doing field work. So I also, which I had always done ever since I started my studies in biology. That means going out initially in Europe, going to cave sites, and you're going to actually look for new fossils. And in Africa, that was of course very exciting. I teamed up with Leakey, who's a very well-known colleague who were from the Leakey family. She worked up north, really in the desert in northern Kenya, close to the Ethiopian border, and I could come and join her, and then we would be 3 months of the year or so. We would be out in the desert, exploring, walking around with a team of about 25 people looking for fossils for us, and we would direct them and look at the results and study. And I've been doing that for quite a while. So then automatically I got the task that as an anatomist, when we did find new fossils, that I was then allowed to study those for the team. I really became part of the team and do the descriptions and the interpretations of what it all meant for an understanding of our past.
So just this question occurred to me. How do you know where to look for fossils?
Well, that's a very good question, actually, because Africa is a huge continent. And I mean, we focus on Africa because I am particularly interested in the early parts of human evolution, things that happened before 1 million years ago, approximately. I have colleagues, for instance, a well-known colleague is Chris Stringer at the Natural History Museum. He works a lot on Neanderthals, very famous sort of, it's not really a human ancestor, it's more sort of a cousin. But they lived in Europe and in Asia, but not in Africa. So if he does any field work or interacts with fossils, that's all happening more here in Europe. But I wanted to work in Africa, and Africa is huge. The answer is how do you know where to look? is in practice is very often that you have to rely on geologists, people who go out, and that happens very often already at the turn of the previous century. So I'm talking about 1910s, 1920s. People would go out, and those were really, the seriously Indiana Jones times, because you didn't have any satellite phone or even radio or anything. These guys would go out and would just walk around in the desert, usually no tent or anything, just sleep on the ground, and you team up with the local tribes, get your food and whatever, well organized. And they would describe the geology, because that was all, there was a geological survey of Kenya was associated with the government, and they would map everything that was going on in this case, then particularly in what you call the Rift Valley, which is sort of a rip in the crust of the earth that runs up through Ethiopia, down through Lake Turkana, through Kenya. That's a place where the different plates that make up the crust of the earth, where there's sort of a lot of movement going on. And if you look at those reports, then you very often can find that they report that they see fossil bones. Some also even can see what and how, and start to describe what kind of animal it might be, certain types of elephant or certain types of hippopotamus. And if you go back to those reports, then you can start off. Now, when I joined the team where that I work most with in Kenya, then a lot of all of that had already happened, and the sites that we have been discovered by Richard Leakey, the husband of Maeve Leakey, in the late 1960s. And that was actually complete luck. He flew over in a light aircraft, one of those little Cessna planes. He was on the way flying from Nairobi to Ethiopia, where he worked with some colleagues from the States and from France. And the anecdote is actually even that there was a thunderstorm that drove him away from his normal route, the way he would fly up from Nairobi, and so he flew, instead of on the west side of Lake Turkana. If you look on the map of Kenya, you see that in the north you have this really long, stretchy lake, beautiful, beautiful long lake. So normally he would fly up on the west side, but this case, thunderstorm, he had to fly on the east side. And he looked out of the window and he sort of saw the sort of rocks that he would see there, that he would think, that doesn't look at all like rocks that come from volcanoes, for instance. And when the lava comes out and it solidifies, that gives a certain picture, but there's no fossils inside, because it just comes out liquidly out of a volcano. But when you get rock laying around to this, like sandstone, for instance, that's really rock that formed in the bottom of a lake or the bottom of a river. And very often then you get the remains of animals sort of mixed up with it, and they fossilize inside. And if then the rock erodes away again because of the water table sinks and you may get water action or the sun, everything, it erodes, and then you can see the bones coming out. But that, even from an airplane, you can see what type of rock it might be. So he actually went back there after a few weeks and inspected it, and then discovered that there was a huge area where there's lots and lots of animal bones on the surface. And on that first trip, he actually even found a few stone tools that were primitive tools that had been made by something that looked like human ancestors, perhaps. So he realized that this was really worthwhile doing, and he got support from the National Geographic Foundation in the States, and ever since there have been big expeditions to this whole area around Lake Turkana, and it was a privilege. It's always been a privilege for me that I can join them and be out there. I mean, it's fantastic that for your job you can actually go out and live out in the desert in a tent, and yeah, it's sort of as if you're paid for doing a safari. These days, there's not that many animals anymore. That is less and less, unfortunately. But there are areas where you still have giraffe and lots of gazelles, and occasionally you hear lions in the distance and whatever. So that's good fun.
And how long did you stay in each mission? How long do they last?
Normally the field seasons, at the moment we're actually sort of in a quiet moment when we, of course now because of COVID, but even before that already, because we, for 10 years we really worked very hard there. But the pattern that happened was that there would be 1 or 2 field works that would be 3 months long. So I would normally, when I was finished with the students at the medical school at UCL in June, I would fly out there, and then June to July, August, for 3 months I would be out there. And then you still do some work in the museum in Nairobi. And then in the winter I would go back, and then I would do work in the lab to sort of, clean it all and study the fossil. So a lot of time altogether, and very worthwhile.
And I've never touched a fossil. Definitely not a million. So yeah, are they fragile? Are they like? Are you worried?
It can completely vary. You have ones that are rock solid. They can tumble around and not much happens. And there's others. Very often when they erode out of the sandstone layers there around Lake Turkana, you have mostly indeed sandstone, because it's what you call deposits. So the way the sand was coming down in the lake or in the river system. When that comes to the surface, the bones come on the surface. It sort of naturally erodes out by rainstorms and a bit of sun here or there. If they're then on the surface for a longer period of time, they become more and more fragile. And one of the worst things that can happen, often if there's some fossils around on the surface, they keep some moisture around from rainstorms, and therefore trees and plants quite like to grow in that area. So we've had situations with some very beautiful fossils where actually a tree had grown straight on top of it. And that's really tricky, because then you have to be very, very, very careful, because the roots of trees often have acid in it, and they started really to attack the fossils themselves, and then they became very, very fragile. So then you spend a lot of time, not grain by grain, but still very careful with usually we use equipment that we get from dentists. This type of stuff that they poke around with in your mouth when you go to the dentist. After a while, they're finished with it, and then we had some dentists who would save them for us, and we would have all these picks and all these in different shapes and you use that to, once you discover fossil, you then very carefully have to dig it out, and sometimes that can take a few days. And you then enforce it every time. So you make sure that the moment some bone is exposed on the surface, then you impregnate it with some chemicals that make it hard. And if you're patient, that's a real job where you don't. We get students sometimes, and they tend, especially if you haven't been in the field that much, then everything has to happen immediately. And so this is really one of those jobs where you just have to be completely zen and relaxed. And if your speed is up, then you make mistakes and things start to break. The same applies, by the way, for finding these fossils, because you don't start digging a hole in the ground suddenly and, hey, there's a bone. You usually we work with a team that we train. So we train them in recognizing the shapes of bones. And very often they're people who live locally, and they have a completely different eye for the environment. They, like when we walk through a town, we know immediately, walking from A to B, oh yeah, that's that shop on the corner, there's there, I know exactly where I am. If you walk in the field with a local person, to us it all looks the same up there. Every valley, every bit, there's hardly any trees, so it's really sort of more desert-like. But they know exactly where they are, and they also are acutely aware of what's on the ground. So they, if you then train them what is of interest, they go around all day in a group with about 25, and if they see something that they think might be important, they report it to a foreman, a person that heads a team of about 10. In the old days, they would then just build a little cairn with stones so that you can find it again. and then the researchers would come out and look at what was found the day after or something. Now we live in a computer age, so they all have little handheld computers, and they take the GPS coordinates where it is. They take a digital photograph. They it all gets plotted. So in the evening, after a team of 25 people have been out looking for fossils all day, they give us a whole set of images and all the information to look at. And many of them are very good, so they already know, oh, where there's a thigh bone of an elephant that I found, or it's a broken piece of a gazelle, or this or that. And of course, great excitement if they think that it might be a bone of a human ancestor. Then we look at the photograph, and very often you can already see what it might be, or if it's not clear, then we definitely put it on the list. And then we make a nice list. We upload the coordinates of the GPS on our own GPS, and the next morning we go and walk. Then you walk sometimes 6 to 9 hours or something. You go from place to place, looking for the things they found, and then examine it. And if it's important to collect, then you set up a collection where you start preparing the bones out. Sometimes they're loose on the surface, so all you have to do is just pick them up. And it can be anything. That's the great fun of it. Students are sometimes a bit, they when we send them out with the teams that look for fossils, they get sort of impatient because they don't find anything. Why do all these guys see everything and they walk around and they just don't, what we call, they don't have their eyes in. They don't, if you have, let's say, teeth are very, very hard, of course, with the enamel, right? So fossil teeth is one of the things that you found the most of. But if you have some fossil teeth mixed in with some pebbles here or there, then it's really, it takes a while that you suddenly out of the corner of your eye say, hey, that doesn't look like a pebble. Let's have a look. So if you start off, you come as an undergraduate student, you come out with us and looking at you, then you don't find much. There's always elephant bones, as already said, and hippo bones and these big animals around as well. And so you always find something like that. Yeah, that's in itself. So then if there's stuff that we really like, then it has to be excavated out. So with the dental stuff, and of course we make lots of photographs and et cetera. Sometimes you even build a plaster cast if it's really fragile, as I described with the tooth roots, that it because the acid takes all the calcium out, so it becomes very flimsy. Then you impregnate it with some resin to make it hard, and what you then still do is you use plaster to put a cap over the whole thing, and then you turn it upside down, and then you can safely completely pack it in plaster and take it to Nairobi, and then or to one of the field stations, and then take it off. So there's a whole protocol for that now. So yeah, it's exciting. I partly helped develop all of that. But what I really like about it is that the real exciting finds is only a few times. If it's once a week, then that's a lot. So what's good fun is that you spend a lot of time looking at a lot of bones of all kinds of different animals. There's always something to discuss. There's also very often something that you just see, of the animals around. You might see just when you go early in the morning, you want to go before it gets really hot. So you might still spot a snake or some bird or some whatever. So that, yes, it's very different from city life. So that's the part. Of course, there's, as an academic, a lot of research done, but I truly like that fieldwork part as well.
So I'm getting the impression that your field, like, it could be revolutionized with a simple little discovery somewhere, and like. Well,
that's yes. It's interesting that you say that, because that impression is sometimes given in the press, and if you would go back 30, 40 years, then that was perhaps still possible, but because all the research and all the fieldwork into where we come from, human evolution, has been quite prestigious and well funded. A lot of people have gone out to look for things, and a lot has been found. So what you get is that it's extremely rare when you really find something that is completely unexpected, and that's just how research works. It's the more you learn, the more you have to start filling in gaps of what you don't know. It's not that you make a find and then it's the cliche that you sometimes see in the press, and it comes from the media reports, of course, when people want to sell their publication of something important. All the textbooks have to be rewritten now that we found this new thing. Well, the reality is that that's really rare. And the other cliche that you still hear sometimes is like, oh, all the fossils for human evolution can fit in a shoebox. And in fact, we have thousands of them. It's really, and it makes sense because ever since the end of the 19th century, people have been very hard at work to find these things. And with modern technology, with remote sensing to look for the right places, even from space with satellite photographs. Not that you see the fossils with satellite photography, but you can see where the right sediments are. These sandstone banks, those you can spot. They look different under different lighting. So you can use all these sort of modern gadgets to find things. So the big picture of human evolution as it stands is very well established, and it will be very rare. Often when you then find something new, it's not that it overthrows everything that we already knew. It just adds something very new to it. There's two reasonably recent examples of that. Around 2003, some colleagues were digging on an island, the island Flores in Indonesia. It's a small island, and there were reports that some stone tools had been found. They dug a hole in a cave, and they started finding human bones, but looked completely different from modern humans. And it turned out that on this isolated island, they discovered a species, a different species of human that had just developed there completely in isolation by being on its own on that island. The ancestor was probably a human ancestor that lived on Java and other islands of Indonesia, but it got across to this island Flores. And that's a phenomenon of animals that come onto an island and then develop all by themselves. That is quite well known. There's very famously in the Mediterranean, for instance, African elephants have multiple times ended up on Malta and on Cyprus and on Sicily, and you would get that in the environment of the island, they would change completely. They would become smaller and smaller and smaller until you had elephants that had the size of a pig or a hippopotamus. So that's evolution very quickly at work, because selection favors to be small there if you don't have enough food, because on an island, of course, you graze away what's available very quickly. And we never had imagined that this could happen to somebody from our family tree. So finding that little because it is the individuals were not much taller than a meter or something. So finding these what were dubbed the hobbits, because at that time there was just a lot of the Hobbit, I think, is from Lord of the Rings. I think is it. So they were nicknamed the Hobbit, and so that's a completely unexpected find. But it is not the case that find completely overthrew everything we knew about evolution. It's just it added something to it that was fascinating, and everybody, to this day, is interested in that. In the same way, not that long ago, a number of years ago, they found a human ancestor in South Africa, and just looking at what it looked like, was in a cave again, not in the open air like we do in Kenya, but in a cave. Just looking at what they looked like, I would have guessed that that creature may have lived about 2 million years ago, but they couldn't really, at that time, establish how old these layers in the cave were. When they eventually were able to do that with radioactive layers, where you look at the decay and you can estimate how old it is, when that became clear, it turned out only to be a little over 300,000 years old. And it's again one of those crazy things. It's something completely unexpected that something so primitive looking was still around 300,000 years in South Africa, in southern Africa. So it added something, but it's not that the rest suddenly turned out to be all wrong. So the big picture is in itself quite clear. There are, of course, big gaps. What can you say? You cannot, you can't find things on demand. But we have a pretty good idea of what happened over the last 5-6 million years.
I'm very reassured by that.
I'm sure you are.
Because the way media depicts it's like, oh, any day we could.
Yes, but there's a big shift has happened over the last 20 years, maybe. That one thing is that universities started, of course, as with so many things in America. Where, of course, you already had a lot of private universities, and that means very often that they have to do fundraising, and that means that they have a media department that is really on the ball. But if you, at Leeds, in a while find some really interesting stuff, then I bet you that the media department, or it used to be the press office or something, that they come knocking at your door and saying, you're going to publish this or that. We have to write a press release for that. And nowadays, even further, we have to provide extra material. You have to do little interviews that can be uploaded. You provide the photographs for it. You might do a blog about it. It comes with this whole package. And because if you write an exciting press release, then people on the radio may say, "Hey, can you come on the Today program in the morning, or can you come on Channel 4 News or whatever and talk about it?" And that may have an effect for the university being known, but also sometimes financially, it's and for the individual researchers, of course, it's important. If you work, you have to prove as an academic that you didn't sit around read the newspaper, but that you actually did something useful. So if you make a lot of noise, in a sense. So it's a fine line. And I think it's also justified in part because, of course, yes, there's still a lot of our work may well be funded from private donors or from various foundations, whatever. But ultimately, there's still tax money going into it. Then you should also be able to explain to everybody in the country what you've been doing and why it's important and why it is that you do this and what you've learned. So, but there is, especially if you get press officers who write the press release, they often make it just that little bit more exciting. And it's a very fine line between it being more exciting and going a little bit over the top. And so that sort of stuff that you refer to of textbooks have to be rewritten, everything is overturned, that very often comes from press officers. And inexperienced researchers don't dare to say, no, I don't want to do that because I can't look my colleagues in the eye. Because, of course, if silly stuff comes out, the next time you're at a conference, then your colleagues may say, whoa, I read this and this about you. What were you thinking when you when you were saying these things?
And doesn't that seriously question the objectivity of the news itself? Because
yes and no. All I can say about it is that there is a mechanism, and indeed colleagues, the peer group, the people that you're with worldwide, that helps a lot. There have been, without naming names, but there have been a few people who would regularly sort of overact the sort of things that they found or draw really silly conclusions about them. And of course, then very quickly you get a name that you are a person doing that. And that has immediately repercussions because when, let's say, you want to go from a temporary contract to a permanent contract, or you have to make promotion at the university or this or that, then they ask colleagues, experienced colleagues in the field, to write a report about what you've been doing. And if they come back and saying, well, this person goes overboard and doesn't do serious research, then that backfires. So it is a self-correcting. It's a self-correcting thing, but you have to stand up. in the same way that, as so many things, if a journalist try to push you in a certain direction to say certain things that you actually really don't want to say, that usually comes with experience, that you sort of notice that. Then you just have to really stand up for it, because yes, credibility of scientists. It's often in the news nowadays. Of course, it's not. Yes, I worked for many years at medical schools, but I've never directly been involved in any sort of viruses or epidemics or whatever. But credibility, good credibility of scientists, including the fact that you should not be afraid to get it wrong. I mean, that is the system. If everything would work as it's supposed to work, then it should really work well, because we all correct each other. Science is all based on, I look at something, I draw my conclusions, I write them up, I say why that is. You cannot write that up by simply saying, I think, I feel that it's this and this and this. No, you have to really justify why you think that is. And somebody else can say, okay, well, maybe I'll have another look at that. Maybe in my case, they may go to a relevant museum and have another look at the fossil, and they say, wow, this guy Spoor, he looked at this or that fossil and he describes this and this, but I actually think that the piece had broken off and it's nicely polished in the wind, and it may not be at all like this or that. I have a different interpretation, and they may write that up and they may criticize it. And yes, it may hurt your ego, but if you're wrong, the point is that ultimately you may get some people who say, you got it wrong, but that actually doesn't really happen that much. It is understood that as long as you try to do the best job you could do at that moment, if it turns out that you were wrong, then then it doesn't matter. The progress of science is that somebody else comes and checks your science. That's actually one of the important things. That is a bit of a debate now and then. Indeed, does that happen enough? Do journals or universities, do they reward research that checks other researchers? Does that get rewarded enough? But it is vital. It's absolutely vital that things that have been claimed should be checked and should be checked again. Because I'm sure you already, done some statistics and this and that. Of course, there's all kinds of stuff that randomly can happen. So in the end, whether it's observations or conclusions, whatever, the whole thing has to add up, and that really only happens by checking and rechecking. And if I find a bone and I think it's a new human ancestor, that's all nice and well, but it really only becomes very established if other people start finding more bones of the same creature, not of the same individual, but they found confirmation independent from me that indeed, let's say 2 million years ago in Eastern Africa, there was a creature separate from the ones that we already knew about, that was alive and that was walking around. So it has to be verified, and that can sometimes take. There's cases in the world where that may take several decades before that happens, and that can be incredibly frustrating. But the key thing remains that, as long as you're not penalized for just trying hard and trying to do a good job, then it's fine. That shouldn't hinder your career. So trust and being, I'm not saying that it doesn't happen that there's foul play or this or that occasionally, but it always got found out. That's the thing. There have been over the centuries, there have been a few cases of real fraud in science, also in paleontology, where people would almost fabricate fossils. That has happened. But you're found out. And if it's not now, there's a famous case where one person glued two fossils together to make sort of a hybrid out of it. fossil out of I think it was from Pakistan, or from China, I can't remember what that. And on the outside, it looked very convincing. But nowadays, I described this sort of CT scanning, the sort of brain scanning that you do in the hospital. But now we all do this with industrial scanning, where you can go to the, to the nearest micron, you can see what's going on inside. So they stuck this supposed one fossil, they stuck it into a microcity, and they looked in detail inside. Well, yes, on the outside it may look nice, but on the inside you can instantly see that the bits don't add up. So that sort of stuff eventually falls through. It's there's always progress in technology. The same way with dating things, how old things are, and sometimes you can also get a signature from isotopes that occur in certain fossils. And let's say the isotope signature of one half of the fossil is completely different from the other half of the fossil, then you know that there's something weird going on that can't be right. So this field, which originally was a bit Indiana Jones-like, if you would go back to sort of the beginning of the last century, but over the last 30 years or something has incredibly professionalized, and people specialize in things. We are heavily reliant on geologists, people coming out. And when we're in the lab, we're reliant on, even indeed engineers, whatever. If you look at certain limb bones, you can actually now stick them in a CT scanner, make a complete model of what the thigh bone of some creature looked like, and you can do what you call biomechanics on it. You can really analyze exactly how that bone responds to forces that are generated by the muscles, the forces that are generated when you walk around. Every time you walk and you step on the ground, and there's a shock going through your heel up through your limbs. And if you actually on microscopic level look at what these bones inside look like, there's a signature that shows that you walk in a particular way. So it's very multidisciplinary, and you work always in big teams, and you try to be creative with that. You get new people in. Sometimes people who never ever worked on bones or whatever, but you sort of figure out like, hey, they have really something new to say. So it's great. Working in teams is always very productive.
Wow, it's a very interesting field. I didn't know how many different things have to come together in order to.
Yes, no, that is the case. It's because originally, of course, for all those years from the mid '90s till I went to the museum, I was indeed at UCL in a department where, well, about 90% or more of the researchers were all lab-based. They would do genetics, or they would do molecular biology, so they would study how molecules respond in the body and this and that. And they would often still come with sort of this image of, oh, you're looking at dusty old bones. That is 19th century science. That's not really modern science. And they learned over the years that that's absolutely no longer the case. It really is. It's fundamentally different often than if you work in a lab. A big difference, for instance, is if you work on let's say molecular mechanisms in humans and animals, you might choose a mouse as a test animal to investigate, and yes, you can basically buy as many mice as you want, and you can do tests and you can do all kinds of experiments, whereas we to the field and we can try to look for things and go by earth layers. We know how old the earth layers are very often, so we specifically target certain things because we're interested in a particular question. At the typical questions of where the three big questions, I haven't really mentioned this, but in human evolution is sort of where we as Homo sapiens, our species, where we come from. Then there's also the question where our whole lineage comes from, the lineage that we are part of. And then and that is something that goes back. Humans, as we think, Homo sapiens emerged around 300,000 years ago. Our lineage emerged somewhere between 2 and 3 million years ago. But the last common ancestor, where the lineage that went to us and that went to the other great apes, particularly to the chimpanzee, that goes back about 6 million years. So these origins you can all study, and they're all contributing. So we can go to certain earth layers to investigate, but of course there's still an element of luck. We can't open a catalog and saying let's order 100 mice of this particular genetic makeup and we do experiments on it. So it has that surprise to it, that you go around there and you look for things. So that makes it slightly different. I mean, same applies to people who study dinosaurs or something. That's the same. The principle is the same. And in the same way, there are people who study fish or whatever. So all life or plants, fossil plants, how life on Earth emerged is just studied by all kinds of different people. But where we come from, of course, has a little bit of an extra flavor to it.
So I guess the question is, what are humans?
A very good question. We are probably the worst ourselves to answer, because it's sort of you ask about yourself, and of course it's logical that any creature that would be conscious, and of course yes, it is the case that probably we are, at least to a sort of level that we can self-reflect, we are probably the only creature around at the moment that can do that. But it makes sense that we see ourselves as something very special and unusual. But in the greater scheme of things, it would be good if somebody from outside could. But of course, that is not the case. So the way to answer that question is, there's actually at least two answers to that. One is culturally and socially. I mean, I can put different hats on. I can say, I look at humanity and, I'm interested in politics, I'm interested in how society goes, and I'm interested in, how people get along together or not get along together, and why is that, and all the reasons for that. So that's one element. Just as a human being, I have an interest. So then you can reflect on that. I can also put my head on as a biologist, as a paleontologist who studies the past, and observe that ultimately, apart from that, in many respects, that last part of that seemingly becoming completely conscious, very self-reflective, and being aware of yourself and where you are in the world. Apart from that, most of the processes that happen to us and what that we are a product of are not fundamentally different from what you see for any other animal. So if you want to say it in a slightly more provocative way, then you can say, well, we're a very intelligent, whatever intelligence means, but we're a very intelligent primate. And that's it. And ultimately, I do indeed think that that's what we are. That is not to diminish ourselves. That is not to say that there shouldn't be any human rights. By the way, that is a big thing. There are colleagues who say, well, actually, chimpanzees and gorillas, they're actually pretty clever too. So they should actually have human rights as well. And that's a whole separate debate. It's more ethics and whatever. But because one key part there is, of course, that if you have human rights, you also have human responsibilities. That you can't do things. But if a chimpanzee, for some reason, in an act of rage, kills another animal, we don't say, "Whoa, we put you in the dock, and there will be a court process, and you will be prosecuted for killing something else." No, you say it's okay. We have to be more careful, but this creature should not be able to do that. So that's a fundamental different thing. So yes, we are a very clever primates, but we should also know that cleverness has emerged, has developed. That big brain of ours has evolved to cope with our circumstances as they are here. So we should also know the limitations to ourselves. That I always think is very important too. So that's, in a sense, also a little bit of self-reflection, that you could say, well, there are things in life that you comprehending. That is the classic thing in that context. When people talk about the size of the universe or even just traveling to Mars, or let alone out of the solar system, and light years and light years away, and let alone all the more hypothetical or the more theoretical stuff about Big Bang and God knows what, or time that is reversible, or any of these things. A mathematician or a physicist can calculate these things, and so far the good news is that by being consistent in applying things like maths and physics, these laws on the whole seem to hold up, or they may have to be adjusted now and then, but still there is something to it. But that is not to say that our brain is capable of imagining what it means that you bend space and time or something along that line, because we evolved to cope with the environment around here. Initially, we evolved to cope with, to live out in the mostly open space in Africa, of the African savanna, or sort of half forested environment, and to be able to cope with all of that. That's not setting yourself up to deal with all these very abstract things. So I have no problem to say there's lots of stuff that I just don't know, and because my brain is too small, or it's you can't really call it too small. It's just not geared towards that. And so the best thing we can possibly do is indeed, and that's a pretty good achievement, I always think, of humanity, that you can come up with things like maths and physical models, physics models. That's if you just take them to their logical conclusion, then it will do a prediction about what might happen or might not happen. And eventually that may, through clever experiments, that may well be proven in some way or another. But that's quite an abstract concept. But yes, a very clever primate. That's ultimately that benefit, and a greatly social animal. Of course, we are a very good and benefit greatly from being from our interaction, strength in numbers, etc., etc.
And when we say we in this context, are we referring to sapiens, or are we referring to humans as a whole?
Well, that's a difficult question. And that's sort of a little bit arbitrary, but it is often a discussion among colleagues, and also especially when you have to start writing things down. Where do you draw that line that you talk about these are humans? Are Neanderthals humans? And now Neanderthals, the more we learn about it, including interbreeding with us, and we took genes from them, they took genes from us, and whatever, the more we learn, there's increasingly the chance that they actually did do some things that looked a little bit like art, which is a different way of thinking, to actually make something either for aesthetical reasons or for some reasons, in some rock paintings or whatever. So yes, very much like us, but on the other hand, the same genetics that's where you can get ancient DNA out of these bones has also really demonstrated that they are a separate group. The problem we have with that is that we are indeed, which in itself is intriguing, we are one of the few creatures in the world that are truly on our own. And I say that if you would go to the Rock of Gibraltar, or you would go to somewhere in Africa, or you would go to somewhere in India or Indonesia or wherever, and you see some monkeys, in many cases, if you could do an interview with a monkey and saying, what's around you, what do you see? Then very often you will say, well, there's a few other monkeys as well, but they're not like me. They're just, they look like me, but their coat is different. They may have a slightly different shape, this and that. Practically any mammal, certainly, but also other animals, always live in an environment where there's more than one thing that is pretty close to them. In our case, at the moment, but I have to emphasize that's something very recent. That is something that only happened something like 35,000 years ago that we became the only human or human-like creature on our own. When the Neanderthals died out, and perhaps a few other species here or there. But if you go back, let's say, to 50,000 years ago, there were modern humans like you and me. They hadn't reached Africa yet, but they were all over Asia. They had actually reached Australia already. Modern humans were already in Australia. That's always quite fun. They were already in Australia way before they got to Western Europe. Western Europe is a nasty little appendix. If you look on the map, and when it's very cold, and the ice, in the Ice Age, these glaciers come down from the North Pole. Half of Britain was in ice and this and that, and all of Europe was not the most pleasant place. And in general, if you look at sort of the topography, if you come out of Africa through the Levant and sort of in that area, then the most logical thing to do is to turn right and go into the vast expanses of Asia, and not to go left and end up in that little expansion on that little appendix on the left side that is Western Europe, or that is Europe. But so 50,000 years ago, there were no modern humans yet in Europe, but there were Neanderthals there. But Neanderthals were also in Asia, and humans were there, encountered them there. We know about another human creature that was also alive there. It's a very strange story in the sense we have the DNA from a few bone fragments of this creature, and we know that it's a separate species from that DNA, very clear. But we only have a few bones, and so we don't know very well. They're called the Denisovans. And they were also alive at that time. Then there's this little dwarf from the island of Flores that I was talking about that was also alive. And then there's a chance, at least, there's some hints, but we don't know for sure, that's maybe not at 50,000 years ago. The ancestor of that little creature in Indonesia might also still have been alive. So there's a chance, if you go back 50 to 100,000 years ago, that modern humans were around, but they weren't alone. There may have been 3 or 4 different creatures around as well, and we have no idea what it would be like to walk out on, out of your encampment and having the possibility that you might encounter a Neanderthal or something, and how do you interact? As said, from the genetic and the interbreeding, we know that they interbred, so we know that stuff happened. So, it's not, perhaps most of the time they avoided each other. So that's actually a much more interesting time, because now at the moment, coming back to this thing about who are we and what's going on with this, now we're all alone on ourselves, and that makes it very difficult to put this in perspective. But between 300,000 years ago and 50,000 years ago, they were around. Now, coming back to your original question, what do you call these creatures? You call them humans? Do you call them human-like? Or that's just really a matter of taste. If you go back much earlier in time, the period that I really work most, those very early human ancestors, they're not all ancestors of ours. There's a lot of them that just, they are not really related to us, other than that they're cousins or second cousins or whatever. But some of these really early ones, you could say, well, there was actually not that much more going on than that they were bipedal, 2-legged, chimpanzee-like things. I don't know if you ever saw the movie 2001: Space Odyssey. That's it's from the late 60s, but it's still sometimes on TV because it's the special effects are astonishing for its time. But there's a scene at the beginning where sort of they, from what they thought that it would look like in the late 60s, what human ancestors might look like, and they're really portrayed as basically chimpanzees who, because they no longer had trees around, they started to walk on 2 legs, but there was not much else going on. That has changed increasingly. I mean, all those lines are blurred often, because if I had talked with you 20, 30 years ago, I probably would have emphasized far more that apart from being bipedal and maybe a big brain, also that we make tools and we use tools. But very quickly over time, as people went into the jungle and observed chimpanzees in the wild more, it became clearer and clearer that they also use tools for all kinds of things. They may not make stone tools, but they make tools out of twigs and of all kinds of different things to do. And they even have cultures, because one group of chimpanzees may teach the children, how to make things. And if you go 100 kilometers in a different direction, they may make different things because they have different foods and this and that. So they have actually a cultural legacy within a group. Lots of stuff that we never imagined was possible. So we are not the only tool makers. And you can say chimpanzees are our closest relatives. So, okay, that is then still, okay, fine. That happened then all much earlier. But bizarrely, if you go to South America and you study capuchin monkeys, really relatively small monkeys, but they're for their size, they're actually also quite big-brained. They use tools as well. And they also make tools, very often, for instance, using stones and anvils to break nuts. If there's nuts from certain trees around that you can't bite and open them, they figured out that if you put a nut on a big flat stone and you take another stone and you beat the hell out of it, then the nut breaks. And the fantastic thing with these capuchin monkeys that have nothing to do with us, they're really, they also belong to the primates, but the split is like 25, 30 million years ago. That's really a long time ago. But they figured out that certain stone tools are better than others to do this sort of work. If you have sort of soft tools, you can hammer, but then maybe the stone will break. So they are actually clever enough to pre-plan. They have a bunch of nuts they find because a tree is fruiting. Here you have these nuts. And they actually purposefully remember that there are a place by the river somewhere, perhaps, wherever, where there is hard volcanic rock, for instance, or hard pebbles. You go over there to collect those stones, come back with the stones to where the nuts are, and then they bash them. Well, that is a lot of planning. There's not many animals that have that much planning that you in your mind say, I now have a bunch of nuts, I can't get to them, but I need certain stones to open them. And I remember from a previous trip when I went somewhere, I remember that I saw some of these stones. So I go there, collect the stones, come back hundreds of meters, sometimes even kilometers, and then use them. That is a lot of cleverness. So the lines are sort of blurring sometimes, where we thought that tool use was really something uniquely human, and that only started to happen from about 2 million years ago or something. That boundary has now also shifted a lot. The oldest stone tools that we know that were made by human-like creatures is now 3.5 million years old. It's substantially older than we thought before. That's evidence that comes from around Lake Turkana, from the west side of Lake Turkana. So a lot of things that we originally thought don't necessarily hold true. And that's a very good example of science in action, because of course, initially when those stone tools were found, skeptical colleagues would say, well, are those actually really stone tools, or is that just coincidence that they break? Let's say the rocks sort of bash around in the river when there's a flash flood and there's a lot of water coming through. They bash at each other and then they look like stone tools. And others may say, well, they may well be stone tools, but are you sure that they're really 3.5 million years old, or 3.3 million to give them more exact date? 3.3 million. Are you sure that they really are 3.3 million years old, or is it all mixed up in some way? Yes, and then the only answer to that is let's really look very, very carefully, find more of them, that you see a pattern where statistically it becomes incredibly unlikely that this is just random bashing of of stones on each other, so you can statistically prove that these are things that are sculpted by something. And you can do all the geology and the thing, studying the layers to see if they truly came from those layers that, or in whatever way, have been dated to that old age. And it takes several years, but there comes a moment when more and more colleagues are then convinced, and it becomes more sort of established. And the consequence then is that more people will start looking for stone tools in other layers as well. So that's real progress. You're always met with a certain skepticism. If you just find a beautiful fossil that looks good and it, isn't that, then yes, in a sense that's, people say, wow, that's a great find, fantastic. But that's only lasts so long, because what's important is what you do with it and what it all means.
Yeah, I think there are a lot of very big questions that we could ask that are probably very important, as we want to understand what our nature is. Well, but there probably, I guess, is no answer to them. So, for example, what was the behavior patterns of early humans? Did they have language? Did they have culture? Did they have art and music? Did they sing? How did they arrange their societies? Were they violent or peaceful?
No, of course. And in different ways, all these elements are important. And of course, the moment you come closer to us, some of these become more important. Already briefly hinted at it, the question whether Neanderthals would make art. We know that Neanderthals and also many of the predecessors were extremely skilled tool makers. It's not easy if I give you a big block of flint, for instance, and say, well, try to make a nice sharp knife out of this. We all make a mess of it, but these guys really, they would look the whole thing, they could exactly see where the weaknesses are and this and that, what to avoid. And there are humans, there are colleagues who study that and who got those skills themselves as well. And very often you can then reconstruct behavior by, for instance, we have situations where you find a Neanderthal encampment where they were sitting right there making tools. Sometimes you don't find the tool itself, but you find all the shards that have been knocked off to create that knife. But sometimes you find the tool as well, and you can literally glue all the pieces back on. And by studying that, you can actually sort of get a little insight in the mind of the pre-planning, and why knock that off before something else? Because and very often has to do with, can you sort of anticipate what's going to happen in the future? Now that's all very utilitarian, but making art, making a picture, which we of course know from modern humans, from Homo sapiens, in different ways in different parts of the world, but the oldest paintings that's made on rock surfaces are now known from Indonesia. For a long time they were known from places like in France, because you have nice caves around. It's always very important to remember that, because you find these rock paintings in let's say in France initially, and you can say, well, we don't see any rock paintings in Africa, when Homo sapiens evolved also specifically in Africa. But then it's very good to remember, yes, but there's no caves to paint on. And you laugh, but it is remarkable how many times people in the past would still have said, like, something unique happened when humans entered Western Europe and they started to make these beautiful cave paintings. There was like a revolution in intelligence and this and that, until people pointed out that, for instance, in making what you could call jewelry, taking tiny little shells and making little holes in them and clearly stringing them up in things, that happened way earlier in Africa. And yes, those humans were not living they were not living in an environment where they could paint on the wall, because there were no walls to paint on, because there's no caves. There's just, that's just the environment where they live, and they express themselves in different ways. So, but that expression is going on. Now there's a few cases where it's controversial, but where there might be in Spain evidence for Neanderthals at a time when modern humans were not yet in Europe. That a creature, and the only human-like creature that was around were Neanderthals. That you find sort of slightly more abstract patterns drawn on the cave wall, often with charcoal and with ochre, so that's sort of a yellow or a reddish color. So there's some evidence that Neanderthals did that as well, and it absolutely doesn't seem to have any purpose. So that becomes why do you do this? A colleague of mine from the Netherlands who works a lot in Indonesia, she studied old collections that were collected from Indonesia, and she discovered a shell coming from an excavation that is at least 500,000 years old, so 500,000 years old. It's even a predecessor of Neanderthals and modern humans that lived there at the time. And that shell has if you hold it against the light, with the light sort of shadows, you see a whole hatching pattern on it. Probably using a crocodile tooth, very sharp, and there were a lot of crocodiles in that environment. With a crocodile tooth, somebody that representative of that creature had made a hatched pattern in it. Now, and it's generally well accepted that's the case. The question is, of course, why is that? Has that a purpose, or was that a creature that was really bored and sitting there and waiting for some friends to come along so that they could go on a hunting trip or something like that, and was just mindlessly making scratches and making a hatch pattern on a freshwater mussel shell? So we don't know exactly, but it does show you something of the behavior. And what I told you about the capuchin monkeys, that they, in a pre-planned way, go to places to collect stuff. That's the same thing. That you get an insight of behavior of our ancestors by studying, for instance, if they make stone tools. Very often you can instantly recognize where the original material comes from. So it's been transported sometimes 10 kilometers. So you can then see, the simplest thing that you can see is that individuals may go to the source where those rocks are found, and on the spot they just bash it together and make something out of it and take it with them or do something with it. But if you actually go over to that spot, collect that material, bring it to camp, and then start making some sort of hand axes or knives or whatever with it, or things to grind stuff, perhaps bash bones to get the marrow out, whatever, all that sort of, the more pre-planning there is, the more sophisticated the behavior is, the more, concepts like tomorrow or whatever, if you think about what we know about what great apes, what they can do, and lots of other animals that can be seemingly very clever. There are still concepts like the whole concept of tomorrow, meaning you go to bed, you sleep, you start a new day. Tomorrow I'm going to do something that is unheard of. No other animal does that. You may have completely sort of genetically programmed behavior in all kinds of creatures, where you're just driven to do, you go, birds start to migrate at some stage. But there's no evidence that they positively can imagine them, that they will be alive tomorrow and are then going to do something specific. That is a concept of yourself, self-awareness, putting yourself in the landscape. And that has not emerged suddenly. That is something that just gradually started to happen. And exactly where the line is difficult. So with all this evolution stuff, by the way, I should immediately say and emphasize is that just imagine that we would have the most beautiful fossil record where of every generation that was alive, we would find fossils. So thousands, or well, probably hundreds of thousands of fossils for every generation going on for 1 million years or whatever. You can all line them up. At that moment, it becomes nearly impossible, or it becomes simply impossible to draw a line that this species evolved into another one, because one. So the fact that we recognize this is a dog and that's a wolf, or this is a fox and that's a dog, that is because we look at it at the moment what's going on. But if you would go in time travel and you go back in time, you find a moment when the domesticated dog comes from the wolf, and early on it's impossible to answer the question whether it's a domesticated wolf or still a complete wolf, or is this already a dog, because of course things not by magic suddenly become something completely different. Even if evolution is very fast, which sometimes it is, sometimes it's gradual, sometimes it's very fast, but it still takes multiple generations to change. And so everything in life, it's a tree of life, literally, like all the twigs. Everything alive on this planet, as far as we know, is in some way or another is connected with each other. You have to go very far back in time to really come to the very beginning. That doesn't have to be, of course. Now you get more philosophical about origin of life and that sort of stuff, but it's theoretically possible that life emerged more than once, and in that case you might have two completely separate trees from each other. But as it stands, everything that we know, we share. The way we know that everything also fits together is because the very basic aspects of life, our body plan, the way we are formed, and what kind of genes steer us into the way we grow, we have in common with insects and with worms and with all kinds of things. A lot of these very basic, when you think about computer code, a lot of the basic computer code of life, of how you do stuff, is often shared by practically everything that's alive, that has DNA, for instance, and does it in a way. I mean, a good indication for life emerging in different ways is if with one complete group of creatures that would have DNA to pass on their genetic information, and there would be a whole group of others that would use a completely different molecule to do that. That would sort of give an indication that there's something fundamental going on. But actually, as it stands, okay, maybe variety on it, but ultimately DNA is shared by if we exclude viruses for a moment, things that are alive here are DNA based. So if you really zoom in and saying, where do you draw the line? And then I come back to that same question again. You draw the line of, okay, what do you call human? What do you not call human? If you have one snapshot in time, it's easy. It's easy to say that we are human and chimpanzees or monkeys or whatever are not human. I'm sure that you can go back in time, that there's moments when it would become very difficult to imagine what's going on. And as long as you reflect on the fact that that's the nature of the beast, it's entirely predictable, then yes, it's not a problem. You just know your limitations. That's so often with science. Know in advance if those are questions that you can actually ask.
Do we know why humans started walking on 2 feet from the common ancestors, from whatever the creature it was? We assume it was 4 legs.
No, again, you've done your homework well, because that's of course, because ultimately, if you ask people what makes humans, being on 2 feet is important. Having a big brain is important. We perceive that, of course, is very important, having a big brain. There's a few other things, are the way our face is built with a relatively small face, and whatever, we don't have a snout like a chimpanzee or a gorilla. that comes into it as well. But the big brain and the walking on two legs is really very characteristic. They happened at completely different times. The big brain is only something that truly took off about 500,000, less than a million years ago. Whereas the evidence that we have for walking on two legs, that goes back potentially 6 million years. So for a long time, being on 2 feet, being on 2 legs, that was the really thing that set us apart from other primates. There's no other primates that routinely specifically walk on 2 legs. So why is that? There are gazillions of options that's been proposed. The problem is, once again, if you actually really think about it, how do I truly prove that the reason that you bring up? You can come up with very good hypotheses, but how do you disprove? This is one of the curses that we have as paleontologists, that if you would work in the lab and you study genetics or you study molecules or whatever, you can usually set up an experiment where you modify something and then you see if something happens. So you set up a clever experiment and you can see if there's a direct relationship. I tweak this and something happens, and it may look like it. But the problem with evolution is we can't replay, we can't do an experiment and say we change, let's say, the number of trees that are around. One idea is, it's still ultimately the most likely situation is that going very far back. So if you approach the moment of where chimpanzees and humans had a last common ancestor, somewhere between 6 and 8 million years ago, around that time frame, it's very likely that our shared ancestor was living a good part of the time in trees, maybe on the ground as well, but then using on 4 legs like chimps do most of the time. Having said that, same story. If you actually give a whole bunch of tasty fruits to a chimpanzee, then they're almost human in their greediness. They would grab with both arms. They would grab as many fruits mangoes or something like that, as they can possibly carry, and they will walk off on 2 legs. They're waddling. They're not very good at it. But they can walk. But you will see that their knees are bent, and you will see that their hips are really bent, so they can walk like 100 meters. But it's effective for them because they grab all the fruits that they can grab and walk away from the competition. Because if their supposed friends come along, and it's a dominant male or something, they might beat them up and saying, give the fruit to me. So getting out of the way and carrying all that fruit around, they even do that. But still, the earliest ancestor was probably largely a climbing animal, like majority of primates are. So at some stage they got out of the trees and more on the ground, and so the reduction in the number of trees that is associated with the environment changing and becoming drier, so that you get more savanna and fewer forests in Africa. And we have good evidence for different periods of time when that happens. That is probably really a driver. Now you can ask yourself, why did humans then start to walk on 2 legs instead of, let's say, baboons or any other monkey that is on the ground? Or if you go to the zoo, half the time they're on the ground, and then you see they just walk on all 4s, and they just put their hand flat on the ground. One idea of why that would be is that we were such dedicated climbers that we really had a hand that was very good at grasping, but not very good at flattening out our hands. There are different solutions to that. If you actually look at what a chimpanzee or a gorilla or an orangutan, all our relatives close by, what they do when they come on the ground, they also don't put their hands flat on the ground. They actually walk on their fists. They'll very often put their fist down, and they then walk on that in different ways. So there is a possibility, among other ideas, that our hands at that time were not so good at sort of stretching out the fingers to go flat. So you can walk on fists, but you can also just particularly when you do any carrying, if that sort of carrying that you see in chimpanzees, if that's part of the package, then there may be an incentive to just imagine indeed, as I say, the chimpanzee that runs for 100 meters with holding all the mangoes to run somewhere else. If you start off running from one tree to another, you have a forest, and you prefer to be in the trees. You might, in the ideal circumstances, jump from one branch to another. You never have to get to the ground. But if there's fewer and fewer trees, so you get gaps between the trees, gradually over time, as the climate changes and you get fewer trees, you may have to start running on the ground to get from one tree to another, to sleep in the tree, to escape from predators, a bunch of lions coming around, escape from the thing. So you have to get on the ground, and there may be incentives to do that by running on your hind limbs. And it's a very early adaptation. Now, all those ideas are interesting, and all some very clever ways that you can investigate it further by indeed looking at the mechanical properties of the bones. What was this animal actually doing? But ultimately, you can't do an experiment where you say, let's take these creatures, and I divide this group into test groups, and one I stick in a forest with a lot of trees, and one I stick in a forest with a few trees, and I'm going to see how they are going to differ. That's just an experiment that you cannot do. You cannot replay very easily how that will work. So that's very frustrating. Also, because another way that you can sort of test this sort of evolutionary patterns is if you see the same thing happen over and over again in all kinds of different animals. But our big brain and our walking on two legs, our bipedalism, as it's nicely called, is rather unique now, as it is now. As I said, you only have to go back 50,000 years, and there were multiple ones around. But it is quite unique. So it's difficult to look for examples where you see the same thing over and over again. I mean, in animals, let's say you see an animal that a bit like us, that eats a bit of this, a bit of that, that are omnivorous. So you eat some meat, you eat some insects, you eat plants, this and that. If you see in an animal group that are like that, and you see that they start to specialize on plants, then completely independent in all these different groups, you can see that the teeth of those creatures is going to change to cope better with just grinding plant food and not slicing meat anymore. So you see independence from each other, the same pattern in evolution over and over again. If you become, if you start to specialize in swimming, you might see that stuff happens in your limbs to cope well with swimming, because you create pedals and that may well be created from limbs that originally were meant to climb with or whatever. So there are ways of studying it, but we're not very lucky with the things that we do as humans. That no creature that we are aware of has ever grown a brain so big as ours. So why is that? I mean, if I'm really sort of slightly skeptical, but it is something worthwhile thinking about. We, of course, think that having a big brain is really important and very, very clever, literally, and also, the best thing that could ever have happened. But you could be cynical and saying, well, our big brain creates so much trouble. That big brain is used to create atomic bombs and do all kinds of nasty things. And we change the climate with all the rubbish that we do, if 500,000 years from now, it doesn't have to be tomorrow, but 500,000 years from now, we just destroyed our environment completely and we made ourselves extinct in some horrible accident. You could argue, well, that big brain and being all very clever and capable of manipulating your environment is not a good biological adaptation. You're better off if you're a mouse or if you're whatever, and you're resilient and you just get on with what you're doing, but you don't influence your environment so much. So if you try to look objectively at it as a species, Homo sapiens, as I say, emerged around 300,000 years ago. That's relatively young, and completely looking like us is probably more 200,000 or even a little bit younger. So we're really a young creature, and we still have to prove ourselves. So we'll see if we're so good. And then, objectively speaking, you can say, what does it mean to be successful? Creating a lot of copies of yourself. You know, by that means there's lots of bacteria, and even by biomass, if you would weigh every single creature by biomass, or number of individuals, then there's lots of species out there that are a lot more successful than we are. We look at it as humans and saying, wow, look at us. And of course, it is to some extent true that there's no creature that probably manipulates their environment as much as we do. I say that with some caution because, of course, even at something as simple, if you would go back very long in time, the original atmosphere of Earth didn't have oxygen in it, and at some stage, certain algae and things and plants started to produce oxygen, and it is a completely toxic gas. So you could say that those creatures at that time manipulated the entire Earth atmosphere and created something that led to enormous mass extinction of all kinds of creatures, and everything had to adapt anew. So they probably at the time also, if they could think, they would think that they were absolutely brilliant in manipulating the world. So it shows a little bit you ask very good questions, but sometimes either it's we know with the bipedalism, to come back to that, we because of all the fossils that we have, because of all the biomechanical studies that we've done on them, there's some very clever things. If you really want to see behavior of what really happened, then ideally you would have something in the bones. Let's say when you're a toddler and you start to walk on two legs, right? That's the moment when you actually start putting forces on your legs in full, when you go upright. As a toddler, you still crawl around on fours. If you would find that the bone structure would then change substantially, that certain parts of the bone would be enforced, bone would be stronger, thicker and stronger, and this and that. And you could actually study that in fossils. You could see that process happening. Then you know that going upright was actually really actively happening, because it's a trait that is being acquired. So there's a lot of people who really try very hard to come up with these things. But ultimately, they ask the questions, why did we become bipedal? Why did we grow a big brain? You can come up with different hypotheses, and many of them you can actually reject on the basis of that it just doesn't add up with the evidence. But you end up with a number that are plausible, and that's what you're sort of left with.
And did the bigger brain make us weaker, as compared to, for example, chimps? They seem to be much stronger than us.
They are very strong, although that's if you would ask a chimp, not that you can, but if you ask a chimp to do push-ups, for instance. So they have very strong arms, and of course they're climbers, and if they let their arms hang next to their body, then they can touch the knee with their fingers. And it already showed their arms are really long, ours are short. And indeed, yes, they can easily pull themselves up on one arm. And it has to do with partly with how the muscles are built and how the skeleton is built, but it also has to do with the structure of the muscles themselves, if they're good at producing power. And our muscles are actually very good at repeat exercise, and not necessarily so much at producing enormous amounts of power. So we can run a marathon, but a chimpanzee couldn't. Okay, it doesn't have the legs to really run that efficiently. But if it was a swing through the trees marathon, they would also run out of energy. So if you ask, with these big, strong arms, can you do now 50 push-ups or something like that? I have a suspicion that they may well run out of steam before that, because they're very good at producing power, but not at repetition. So in principle, we are well. I mean, we're particularly that thing, the running thing, is we have evidence that the evolution of the way we walk around happened in two major phases. There was one first phase, one up to about 2 million years ago. So from, let's say, from 6 to 2 million years ago, most of the creatures, or all of the creatures, still partially lived in the trees and were quite capable on the ground. They were certainly not sort of badly adapted, but they were not like us. And then from about 2 million years ago, you see a distinct shift in the skeleton. You also see a shift in the organal balance in your inner ear that I early on mentioned, that I did for my PhD. You see a shift happening, and it looks like what you call endurance running. The fact that you can start running, and you don't have to run fast necessarily, but you can run for an hour or something, or whatever. There's not many animals that can do that. That's a very unique human thing. There's a few, African hunting dogs and hyenas, and there's a few other things, but actually, classically, there are certain tribes in Africa who practice persistent hunting, not much anymore. But the way they do it is they see an antelope in the distance. They sort of in a quite relaxed and casual way run towards it. Antelope runs away. Okay, no chance. Way too fast. Okay, human is clever. Human is very good at finding the tracks of what's going on. So it knows where the antelope went. Broken branches and footsteps. So it walks and slow, sort of gently runs towards where that animal is until you see it again. And you just go after it. Okay, antelope, damn, there's these bloody humans again. I have to escape again. So they runs again. If you persistently do that, you can actually exhaust animals like antelopes and I think even perhaps zebras. I don't know, because horses are pretty good as well at longer distances. But certainly a lot of antelopes, they overheat. They just become exhausted, and eventually humans are capable of catching up with them and ending up with an animal that is half dead because of a heart attack or overheating in the tropical sun. And so that pattern of persistence hunting and being capable of just keep going and going and going, not run the shortest possible marathon time, but just being capable of going and going and going. That's a very human thing, and that has come in, and we're very good at that. So we are actually, okay, our arms, but we're not climbers. We're quite capable at climbing, actually, if you see what people can do with. But very often we also climb with our feet, and so the pushing up. It's not that you just let your legs bungle and you just grab a rope and you pull yourself up. Yes, you can train and you can sort of do that, but the clever way, you actually use your feet as well. So you grasp and you push yourself up. If you see how some populations can climb trees to get to coconuts or whatever, very often they use their legs on the side to grasp as well. So those powerful legs they use again. So the emphasis in our body is very much on our legs. We have unprecedented strong legs, and the arms are a bit more. But our arms, on the other hand, we have something very unique, and that's this thing. That's the precision that we manipulating something. If you put a little thread through the eye of a needle, if your eyes are good enough for that, the fact that you can hold your hand still here, and you go from 1 inch through it for something that is less than a millimeter or even half a millimeter wide, that's a precision that you would not find in any other primate, frankly. So the innervation for all those muscles in your hand that makes that possible is, or playing a musical instrument, whatever, playing the violin, whatever, where it really comes in. If you put it a fraction of a millimeter in the wrong place, it's out of tune. So you have muscle memory that does exactly the right thing. So it may not be so strong, but it's in hands, but it is very very subtle and very well developed.
Yeah, we seem to have very good, well, coordination with our hands and learning ability as well.
Yes, yes, we do.
So do we know why the other humans went extinct, the other species?
No, and that's always been, of course, in particular, the most confrontational scenario of that is what happened to these Neanderthals. In particular, now we know that Neanderthals lived all the way up to the east towards Siberia as well, but the core of many Neanderthals, where they were best known, was Western Europe. We know that humans came into Western Europe somewhere around the 40,000 mark, 40,000 years ago. They encountered the Neanderthals, and 5 to 10,000 years after that, the Neanderthals were gone. Why was that? We know indeed from the DNA extracted from the bones that there was interbreeding and all of that happened. So they at least met each other. But there's been quite a bit of speculation, of course. In wild science fiction ideas, it would all be warfare and competition and this and that. It's also possible that there was indirect competition over prey sources, where modern humans were just a bit more versatile. Combined with, of course, all of this is happening at a time when there's quite a bit of swings in the climate, and humans were potentially just a little bit more capable of coping with change. But I mean, things like size of brain, you may have heard this before, but the Neanderthals, for instance, had equal sized brains like ours. It had a different shape, somewhat different shape, a bit more elongated and this and that, but so it's not that they were stupid. But maybe that for the environment and for that there were small things, and there's of course still also possibilities that there would be introduction of disease and whatever, whether that doesn't seem to rhyme entirely with the relatively long period of overlap. So it's just a subtle change. Any other extinction events earlier on, we really have no idea about why. But if you actually look at when in mammals in general, when extinctions happen, very often it is climate related. They're well adapted to a certain environment. It may not be necessarily be like, oh, it's really cold here now. Now we go extinct. It's very often, I'm a creature that is really well adapted to certain plants or certain things, and then the climate changes and those plants disappear. And with that, everything, all the bells and whistles, all the animals that feed on the plants. Okay, sometimes you can follow the plants around. So if, let's say, it gets colder and colder, then you may see that the more warm loving plants may go further towards the equator, and then the species may follow that. But for instance, if you live in Europe, if you do that, then you get trapped in the end, and it happened literally in the ice ages. You get trapped on the Mediterranean coast until because at some stage, the ice cover of Europe reached the Alps and the middle of Britain, and sort of cutting through, and then just so that the swings of climate could be substantial. Because on the other hand, I don't know if you ever heard that story, but if you dig around, if you would make a big hole on Trafalgar Square in London, you have a chance that you will find fossil bones of animals that lived in a tropical swamp. Hippopotamus and whatever have been found in Trafalgar Square, literally, dating from a time when Britain was subtropical, and on the other hand, as I already said, you have situations where complete ice cover, permanent ice cover, would come all the way to below Leeds. It was just all under ice, and the area directly underneath, all the way to the south coast, would just be the most severe tundra. So it swings back and forth. So with that, you get a lot of extinctions happening. And ultimately, I think even human-like creatures, human-like species probably became extinct in various events. Nothing lives forever. In some way or another, you either things evolve into something else, or because the world, planet Earth, is a restless thing that ever changes, and the rest has to follow.
And what are some of the upcoming discoveries you're most looking forward to?
Whoa, yes. Well, I don't know. I mean, it's apart from, there's of course things that we want to publish ourselves, and I can't say much about that now. But and perhaps a more interesting question is, what are the sort of things that we really would like to know and we would like to know more of? And there's a few, even though we have so many of these fossils, there's a few things that we still don't know too much about. For instance, so we as a species are called Homo sapiens. So that's the bit Homo is the genus name. All organisms have that double name, a genus name and a species name. So that lineage, that all is called Homo, like Homo neanderthalensis for the Neanderthal and Homo erectus as an early one, where that whole lineage of our genus comes from. That is the earliest really very clear evidence comes from about 2.3 million. There's a little bit of evidence from around 2.8 potentially, but it's a time period in Eastern Africa when we don't find many fossils. Has nothing to do with, it's just bad luck. Again, has often to do with climate, that the process that you create fossils, that fossils are created, is particular special circumstances. You need a lake system or a river system where cadavers float around, bones come on the bottom of the river or the lake, and sand will drift on it. But there are also periods of time when actually there's hardly any lake. For instance, Lake Turkana that you see now, if you look on the map in Kenya, there's been periods when the lake was much bigger, but there were also periods when it was just a measly river in the middle, and all the stuff around it was just dry land. And at that moment, you don't get any fossils there because fossils emerge in very specific circumstances. Caves is always a good one. You very often get that carnivores, leopards and that sort of creatures, or lions, but leopards in particular because they often hang around the openings of caves. They grab a gazelle, drag it into a tree that overhangs a cave opening or something, eats the gazelle, and the bones just fall in the cave. And very often you then get that cave sediment sort of go over the bones and it fossilizes. So caves are very good at creating fossils. And indeed river and lake systems like we have in the Rift Valley. But there are periods of time, for instance, between a little older than 2 million and 3 million around Lake Turkana, exactly the period when our lineage emerged. That just there's a few places where there's layers of the right age, but then often you don't find fossils in them, or you don't find the right type of fossils in them. So finding spots, we often really desperately try to find. So having evidence when our lineage actually emerged, that's something I'm very busy with. There's still, if you go back in time, the closer you get to the origins of our entire branch, our entire family, after we split from the chimpanzees went their way and we went our way, the earliest millions of years, there's very few fossils. And strangely enough, they pop up in the very best, most beautiful fossil that documents this, that is as old as 6, maybe even 7 million years old, was not found in East Africa or in South Africa in a cave or whatever, was actually found in the middle of the Sahara Desert in Chad. And if you study the animals, it's not just a skull of a very early human ancestor, but you find lots of animal bones as well. And if you study those, you find out that at the time when these creatures were alive, that part of Africa was very lush and had there were hippopotamus, again, ancestors of hippopotamus. So the Sahara hasn't always been there where it is. So that was the time when that area was very lush, and it shows again that what's going on right now at the moment is not necessarily how it was in the past. So there are huge parts of Africa to explore, where things may have been favorable, and yeah, there are all kinds of reasons. Either there's not many fossils there, like this. It just happens that this crazy Frenchman was there and found these fossils. Absolutely spectacular, but he could only work there for a start because he had great support from the French military, and the French military is very present in Chad. Something you rarely hear about, but it already shows. It even interlinks with politics and whatever. There are whole swathes of Africa that at the moment, it's well known that Libya actually has lots of parts that are very may well be very productive, both for human evolution, but also for dinosaurs, all kinds of things. And after the fall of Gaddafi, there were lots of scientists saying, "Oh, now we can go to Libya because there's some evidence from." You have to go back 100 years. There's lots to do there. Yeah, and now it's again a place where you absolutely couldn't possibly go. So even if you knew where to go, you can't possibly go. So knowing more about the really early periods of human evolution would be really if that find from Chad would be repeated somewhere else, that would also be really big news. Learning more and more. It's very fragmentary of what we know about those early phases. From about let's say 4.5 million years ago, we know a lot more, and it is a pretty coherent picture of what's going on. Except that we still struggle of understanding where the lineage of Homo comes from, our lineage exactly comes from. But on the whole, there's quite a lot of fossils around. But before that, before 4 million or 4.5 million, it's there's a few things here and there. So it's finding the right places, and yes, it's a tough thing because you have to find things before you get money, but you need money to go there, and it can be pretty expensive. So it's a bit of a, where do you start? Yeah, so there's still lots of opportunities for people to, and we shouldn't forget, for instance, all of the Congo Basin. There's good evidence that that whole part of West Africa has probably always been sort of rainforest, and rainforest for a long time. And forest environments are not good to create fossils. If animals die there and you get bones on the ground, there's always animals around who would actually eat the bones. Plus, forest floor on the whole, with all the roots and the things, is acidic, and the bones just dissolve eventually. So that whole sway of Western Africa, we don't know too much about, but it may well be possible. But again, not very practical. I know that colleagues looked into it a bit. There are some mining going on in the Republic of Congo or whatever, and occasionally things are found. But yes, to start an open cast mine, it is by accident then in that case that you would find something. There must be a reason to do mining there, and then you find in the sediments, you find a fossil, and hopefully you find more. But that's more random. You can't really steer that too much. So plenty of work to do, but I have to emphasize that on the whole, there's a reasonably good picture about if you just ask the simple question, where do we come from, then there's sort of an idea about that.
It's very interesting. Everything that you're doing is basically just trying to answer where do we simple question,
Yeah,
very complex answer, very complex field, very messy results. But
and it is absolutely true. I mean, for a long time, as long as I worked at the university, sometimes journalists would also ask, shouldn't we spend all that money on looking for fossils? Shouldn't we spend that on other things? And I could say, well, in my case, most of the work in Africa that I've done was indeed funded by the National Geographic and not by taxpayers. And my job at the university is teaching medics, teach medical students to become doctors, and I think that's a very good use of taxpayers' money. So that's my defense. Now working at a museum, at the Natural History Museum, you could ask, okay, again, my job is actually funded by a charitable foundation who created the job for me, but on the whole, you can ask that question, and yes, it comes down to there's a drive in humans that they would like to know where they come from, and some people are privileged that they can actually spend their time trying to answer that question. How important you think that is in comparison to other things? Instead of a wealthy individual paying my salary or donating money to the Natural History Museum so that they can hire me, they could also instead have given that money for a composer to compose a number of symphonies or something like that. So that's all depending on your taste of what you think is important for humanity. There is something about knowing where you come from and what our background is that should inform us about who we are and make us humble about who we are somewhere. We are not the rulers of the world who can just randomly do whatever we want to do. It has consequences. So being a social creature and it's a bit of a cliche to say looking after the environment and that sort of stuff. For us as humans, that is important. Millions of years from now in the future, it may not be important at all.
Maybe that's what makes us human.
Yes. Oh yeah, no, absolutely. And even thinking about that and wondering will that be important or will we mess it all up? And meanwhile, there's a colony of humans on Mars, and what's going to happen there? You could argue that understanding the mechanism and what happened with us in the past, where we come from, is more important than the exact details of every species was alive when and how. Okay, that's nice for the people who are really interested in it, but it's more the broader concept. The importance, for instance, for a long time I wasn't known, and now we realize that it is incredibly important. Indeed, the changing climate. Okay, we very likely make the climate change now ourselves, but before that, the climate changes also simply by a number of processes of how the Earth behaves, how it rotates around the sun, that is not completely static. The axis of rotation wobbles around, and with that you get all kinds of trends in changing climate, and that has major dramatic effects on life on Earth. And getting an idea about how that all works and how it all is put together, and how, on one hand, how fragile it is. It, on the other hand, is also not fragile, because it's cynical to say it that way, but if you would explode all the atomic bombs that are currently on Earth, that doesn't mean that all life will be wiped out. There will be plenty of life in some grim way will be left over. People always say cockroaches, whatever, because experiments actually show that you can radiate them really quite a bit, and they don't really die and whatever. But anyway, there will be animals and plants probably alive, and there will be, after several hundred years of radioactive fallout and all kinds of stuff, there will be lots and lots and lots of ecological niches open to be filled, and you get a spirit. We know that there have been a number of mass extinctions over the many millions and billions of years, and these things happen. You know, the last time, of course, meteorite smashes down, dinosaurs die out, and who would have thought that? It's still there is a certain chance that something like that would, or that it's not even a chance. You know that if you look unlimited time in the future, then you know that at some stage another big meteorite will slam into Earth. Now, if humans are still around, they may be clever enough to avoid it in some way or another. Now we get into Hollywood stuff, but it's not implausible, and it's serious enough that NASA and others are looking into that sort of things. How you could, you know, as long as you can track an asteroid early enough, then the sort of impulse that you have to give to it to knock it out of trajectory is actually not that high, etc., etc. But anyway, but that doesn't mean that life on Earth is suddenly gone. So, in the greater scheme of things, you say. When I say these things, the response that you get from people then, so you don't care about humans. So if humans die out, you think that's not a loss. No, of course I think it's an enormous loss. But that's because I am who I am. That's because I'm a human and I care above anything else. I care about ourselves. But I'm also a scientist, so I can sometimes, you're trained to step outside yourself, because if you completely follow your emotions and who you are, then you know that you make wrong decisions. Also, you're in engineering, right? In some way or another.
Yes. Yes.
So there's probably plenty of counterintuitive situations in engineering that if you would just, think, approximately this or that, you get it terribly wrong. And so you step outside yourself as an emotional creature, and you say, okay, let's sit down. Let's do some calculations, and then we can see that this and that and that is the best way of doing stuff. And then you can try to be a bit more objective. But as a human, yeah, of course, I'm as much in favor of looking after the environment and seeing if we can reverse climate change and whatever as anyone. But you do that for the best of your own species somewhere.
And also it's important for those who might criticize like what you do, is to tell them with science you can't pick and choose.
No.
Yeah. So you can't say, I want to have advancements in medicine, but no advancement in physics. You can't really pick. Sometimes you find something, for example, like MRI being like, in physics we made an advancement, then someone in biology said, actually we can apply the same technology here. So
absolutely, yes. And of course we haven't really touched on that, and it's a whole debate of as with medical students, I would have a number of students every year who would, if you would really have a conversation with them, or I meet doctors, like when I work in Kenya, then I meet doctors, especially if I go to the hospital with a fossil, and then they say, what do you have there? I say, this is a skull of something that looks like a human ancestor, and it's, this is 2 million years old, and can we use the CT scanner to get nice images of that? They always say, fantastic, great, yes, and you pay some money and this and that. But there's a good number of people who don't believe that that's truly. They don't say that I'm a liar, that I come with these things, but the idea of evolution. But then you change the conversation and you say, so antibiotics resistance and the way bacteria and other organisms change under pressure in a poisonous environment. All those elements, you see evolution in action. It just happens. It's you create an environment, and if you make that environment not too poisonous but uncomfortable, so that not all the individuals died, and randomly, it's not because they then say let's go and adapt to this environment. It's just out of the billions of bacteria, there's a few mutations that make that some of these bacteria are no longer susceptible for that antibiotics, and they will be the ones that survive and then very quickly start multiplying. So suddenly then understanding the mechanisms of evolution is then very important for medicine. Or what I always in my lectures did is we as humans are certainly not perfectly adapted for being so silly and walking on our hind limbs. So a lot of the back problems that a lot of people have in day-to-day life, and hips that we break later in age, all kinds of stuff, have their roots in a reasonably well adapted skeleton, but actually not perfectly adapted. The sort of trouble that we have with our backache and constantly hernias and all kinds of things you wouldn't find in other primates. That thing of changing to two legs, where all the forces on your body suddenly come under an angle of 90 degrees to where you normally would go. If you walk on fours, you just have sort of four struts that support a beam that is your vertebral column, and the organs hang under it, and that's all nice and stable, and isn't that you go and stand upright, everything comes from underneath. And our strength, because we have completely flexed straight out knees, that has great advantages for certain things. But if you don't do that walking and running well, that is an enormous bash on your knee joints every time your legs step on the ground. So problems with knees that you find, and of course you see the most in sport activities, because then you do more adventurous stuff. You make twists and turns and you do all kinds of things. But we are not a perfectly adapted body. And if you explain to students, oh yes, and perhaps the best idea, we still have muscles in our feet, for instance, that actually originally worked so that our big toe would be grasping, that our big toe would more or less look like our hands, like a chimpanzee foot. They just have a grasping big toe. And the muscles to make that grasping, that make that same thing possible, that can do your thumb like this and have a lot of force that you can really grasp something strong. The muscle that runs here sort of in your thing. You have a small version of that also in your foot, and it has no function whatsoever. It can stabilize a little bit. But that's just heritage. That's just because our ancestors had grasping toes. And it's just it's just there. It's not really in the way, and it helps a bit with keeping your feet together, not much else. Because often you get asked, so why do we have that muscle then? Well, yes, that's our evolutionary history. So I've always been able to use my research to inform the medical students as well. And of course, things like resistance are way more important. There you really have to know and understand what you're doing. So, but there's also, yes, there's a big body of knowledge and understanding that we all do in life, that you can call it cultural or whatever. And yes, who will know what is ultimately important? And as you say, there's fundamental physics stuff that indeed, funny enough, the algorithms that CT scanning was originally based on, the idea that if you take an X-ray beam and you circle it around an object and you measure every time how many X-rays comes through, that you, from those measurements, that you can calculate the distribution of density inside the object as a slice. As a theoretical exercise that had been solved, the maths behind that had been solved in the 1920s. And it was not until the very early 1970s that it was realized that you could use that to build images of the inside of something. And then the penny dropped, and oh wow, particularly for brain tumors, that was immediately applied, and things moved very fast. And as you say, MRI, I think it's basic of MRI is probably in spectrometry, in physics, that you look at stuff that was well known. At one stage I had a PhD student who could actually create beautiful images just in the chemistry department by just tweaking the signal and the output, and just his knowledge of what to do. And so yeah, you can see how well, you gave the example yourself, how discoveries in one place may not immediately be obvious. And we're curious creatures. We want to know.
And also the idea that, you know, we're not the purpose of the whole universe, right? Just to get a little bit, you know.
Absolutely.
We're just one of many species of humans, and we're actually we're the only remaining humans, and we're actually more close to each other than we think, because we tend to draw lines around each other, around different races, historically different, but different religions. But actually, we're all pretty much the same.
Oh, absolutely, and of course, then yes, you get into a whole different, the whole issue of recognizing races as a pseudo thing. The more we know about genetics, in particular, it's just a no-no. I mean, it's very clear that doesn't work, and that it's not because we want to be so ethical, this or that. It's just about the hard science, about actually understanding. Of course, humans are varied. We are quite a varied species, and we're also quite unique, because you can see we manage more or less to live anywhere on Earth. There's not many creatures around who are so widely distributed. Partly because we modify our environments so that we keep warm or keep hydrated. But we're a varied creature. But the nice thing is that the science actually informs how we should see ourselves, and that indeed superficial ideas, because your skin tone is a bit darker than somebody else's skin tone, once you understand that it has everything to do with the amount of sunshine that might fall on your skin, and the amount of vitamin D that you need or don't want, depending on the circumstances, that makes all the difference. And these things also change enormously fast in evolutionary terms. So in that sense, it can inform a society as well to think more in a sort of slightly civilized way about yourself. And indeed, ultimately, I think all it does is, I mean, I have had people asking, if that's just what we are, what's the purpose of life, this and that. Well, not everything is about ourselves all the time. So, being a little bit more humble about ourselves, and taking the responsibility for the fact that we are so capable of manipulating things is a very good thing. And now it gets all very much in an ethical setting, but still there's certainly an element of that. But and as said, the response of people saying, "Oh well, if you think that we're just a sort of a randomly evolved thing, then you probably don't like humans, or you don't care." But those are completely different things. And that's also just simply, my emotions are not my emotions are my emotions. So if I intrinsically show compassion for something, then I'm fully aware that if I didn't show compassion, anything that doesn't show compassion on a large scale, for a social creature, will very quickly select itself out of the gene pool, as they say. It comes part in the package. It's sort of almost self-correcting. You could argue. Yes, you can have some grumpy man sitting in the corner, but in one way or another, having a good attitude towards your own species is an important thing.
Yeah, and often people are trying to look for purpose out in the outside world. Well, actually, you are the purpose. If you look inside you, if you're not thirsty, you're not hungry. You've done your purpose. Now it's
Yes, and of course, I mean, it then very quickly. I mean, it very quickly gets to a level. It's interesting that that whole topic, human evolution, is done by researchers coming from very different perspectives. You have people like me who are biologists and study it. You also have people who come from anthropology, so really, where there's very often quite a background in social anthropology as well. So they come much more from that humanities side. Which makes it quite interesting to have that discussion, but it comes from very different cultures. I tend, on the whole, to really see us as a biological creature, and because I work on the early part of human evolution, that is also a lot easier because a lot of them were not so human in itself. So I study those fundamental questions like when did we become fully bipedal and whatever. That's all way before we became all touchy-feely humans. So that makes it for personally easier. But when it comes to just thinking about humanity and about yourself and the beauty that you might find in art or whatever, then you obviously just follow your own responses. You look at what's important for you and yeah, that's almost a separate thing, but it has evolved somewhere. Appreciation for art's sake, whatever. Now that's a real sort of thing to decide, but it is in itself interesting that once you see that humans start making something that seemingly is completely non-functional, so something is made for the beauty of it or for something that they're very early flutes made out of arm bones of swans in their wings, of very thin, very delicate bones, and with relatively simple intervention, you can make a flute out of that, because you just have to drill holes in the right places and a little mouthpiece where you can blow on. And initially, people didn't really want to believe that they were flutes until it was really demonstrated that they were truly functioning flutes. And then you think, wow, that might be a site that might be 20,000, 25,000 years ago. People cared apparently about making pleasant noises, and that meant something. Or drawing something that's some of the quite old in some cases. I mean, even the oldest cave paintings that we know have aspects to it that you think there's something there that has to do with abstract thinking. I mentioned a simple example of thinking about the future, but it might also be about empathy. Is of course a very important thing. Stepping in somebody else's mind, that I can think, I can sort of imagine what you are thinking, how you are. I might pre-plan and provoke a response in you because I can anticipate how what I say might come over in you, and that's, well, then you get into this whole theory of mind type stuff, where there's not really evidence, even in chimpanzees, that they truly have that. That's rather debated at times, but that you really can step. It's just not just me, but it's I can displace myself into somebody else, and of course many creatures can learn in some way that if they beat up a fellow creature, then that may backfire because they may have a big brother and they come out and they will beat you even more, and therefore you refrain from it. But the situation where you actually can step into somebody else and think being beaten up is actually not a particular pleasant thing, and if we all stop beating each other up, maybe I'm better off as well, and that's the better way of doing it. That sort of thinking and displacing yourself into something else. That is, that's all part of the package, and intriguing when these things. The classic way where that happens is if we find in the fossil bones, we find injuries that have been healed, and in some cases those are serious injuries, where you would say that we know occasionally from other primates that they may have broken legs or whatever. Then it's debatable. There are some examples where potentially others in the troop may bring food over, but really caring for the sick, where something can heal over time, or really being quite seriously disabled and still being able to survive. That has at least some idea about compassion and taking care of somebody in your group. So it gives a little bit of insight in that certainly emerge. Of course, it's also a good strategy. If you're very cynical, you say it's just a biological adaptation, because looking after each other then that keeps the group stronger, and you can cope with pressures from outside better if you know that you can rely on each other. So you can make it very sort of tit for tat cynical, but regardless, yes, you can call altruism and compassion, you can call those good biological adaptations. Yes, on some level they are, but that doesn't mean that they're not good.
Yeah, exactly. And knowing that something had a biological advantage doesn't mean that you won't enjoy it. So, for example,
no, absolutely, yes.
If I tell you
Certainly.
the reason you like to have burgers is because you were hunter-gatherers, you like meats, but next time you have burger, you're not going to go, damn it, I can't enjoy it now because I know. No, you'll still enjoy it. Same thing with kindness, right? Kindness might have had evolutionary advantages, but it doesn't mean that if someone is being kind to you, it's any less enjoyable.
Yeah. Oh no, absolutely, and of course, when it comes to burgers and whatever, yes, the some of the evolutionary instincts that we still have, that our body has, that really sort of almost steps out of our minds. Adaptation to and just wanting to in when there's a lot of food available, that you rather think let's have as much as we can about it, because then we survive difficult times. That sort of mechanisms in the body that may work against us at times. So it's the whole package altogether. It's interesting questions. Cannot always be answered, but
I think we point out to quite a few things that makes us human. Although there might not be a sharp line between them, but there are many things that makes us what we are.
Oh, absolutely, yes.
And what you're doing is one of the things that makes us human, always wanting to know where we came from, and we're at a point in time where we know more than any other time in the history about our past and the future. So even if we go extinct, we will have at least we might be the only species on Earth who have contemplated about those questions. And that itself, I think, is valuable.
Yes, and that's what's called civilization or whatever. And you could argue, and I mean that in the widest sense, civilization of the entire planet. And the civilization of all of that is there for our enjoyment and benefit. It's not there because it will be a legacy that others will ooh and ah and saying, wow, what's this or that. It's a strategy, and it's the complete picture. It's a way of being that makes our life, if everything goes well, makes our life a little bit better and enjoyable sometimes in small things. Indeed, it's a beautiful painting or a beautiful piece of music or whatever. Yeah, it's a good way of enjoying the planet. And a privilege for us that we can even talk about it in this way, because yes, of course, fully aware that I'm not sure if it's the majority of humanity, but still a good part of humanity doesn't necessarily have it so enjoyable. So, yeah.
Yeah, we can take comfort in the fact that we're advancing our knowledge base.
Yes, you hope so. You hope so. That's despite everything we see around us. That in the end, if you listen to people who really again crack the hard numbers about indeed epidemics and things that happened in the past at regular intervals, and the large numbers of people who die, the plague or any of these things coming through. We do live at a time when ultimately it's not well distributed over the planet, but there is some progress of some sort.
And on that note, we'll end it here. Thank you very
Very
much.
good.
It was lovely talking to you.
Okay, I hope that this is what you were looking for.
No, it was amazing. It was amazing.